Okay. So let's start. Hello everyone, my name is Miroslav Dimitrov. I'm part from the MClimate team, which is over there. And today I would like to talk about quite an important topic, which is smart energy management in non-residential buildings. Not as a concept, but as something that is already happening in real buildings with real constraints and real results. Non-residential buildings, offices, schools, hospitals, public and commercial spaces are responsible for a significant share of energy consumption. At the same time, most of them are not new buildings. They operate with existing heating systems, existing controls, and very limited room for disruptive renovations. So the key question is not whether these buildings should become smarter, but how this can be done realistically, without replacing infrastructure, without complex commissioning, and without stopping daily operations. In this session, I will show how data-driven automation combined with modern IoT technologies makes it possible to gain better control over energy use, reduce unnecessary waste, and introduce scalable improvements, all within existing non-residential buildings. We'll look at the challenges first, and then with the practical solutions that are ready to be deployed today. To understand why smart energy management matters, we need to look at the bigger picture. In the EU, buildings are responsible for about 40% of total energy consumption and 36% of CO2 emissions. So decarbonization simply cannot happen without addressing buildings first. What's critical is that over 85% of the buildings that will exist in 2050 are already standing, and many of them are more than 50 years old. That means retrofit is the main opportunity and not new construction. This is also reflected in regulation. EU policy now targets worst performing 60% of non-residential buildings by 2030, backed by national and EU funding. At the same time, cities are increasingly limiting new construction, pushing renovation as the preferred path. So the challenge is clear. How do we upgrade existing non-residential buildings in a scalable, cost-effective and realistic way? So if retrofit is the challenge, the next question is how do we actually turn existing buildings into something smarter without tearing them apart? The answer is data-driven control. With solutions like this, buildings move from energy waste to measurable, controllable energy systems. Sensors and actuators collect real operational data, LoRaWAN securely transfers it, and everything becomes visible and actionable in one platform, whether that's MClimate Enterprise or an existing BMS. The impact is very practical. Better control of energy use, improved comfort for occupants, progress towards ESG targets, and a clear increase in building value. At the same time, operators gain what they usually lack today: real insight. You can track performance, adjust remotely, and deploy changes quickly, often within a single day, without complex wiring or any disruption. It is not about adding technology for the sake of it. It's about turning existing buildings into smart, energy-efficient systems. Okay, before we talk about concrete use cases, it's important to briefly understand how this technology actually works. For whoever don't know how LoRaWAN works, basically it's a low-power, long-range wireless communication standard designed specifically for connected devices in buildings and cities. At the edge, we have sensors and actuators measuring temperature, CO2, humidity, energy consumption, or controlling heating and ventilation. These devices communicate wirelessly via LoRaWAN gateway, which acts as a simple bridge who forwards the data. From there, the data is securely transmitted to the cloud or an enterprise platform, where it becomes actionable, visualized, analyzed, and used for automation or integration with existing BMSs or software systems. The key point here is simplicity. No complex wiring, no heavy infrastructure, and the same architecture works for one building or hundreds of buildings. Okay, now I would like to briefly share the key advantages of the technology, of the LoRaWAN technology. First, unmatched frequency range and penetration. LoRaWAN has communication capabilities with a range of up to 15 kilometers in suburban areas and up to 5 kilometers in dense urban environments, where it penetrates barriers to reach devices underground through concrete walls or in extreme weather conditions. Second, extremely low power consumption. Devices can operate for years on a single battery, which is critical for retrofitting existing buildings without maintenance overheads. Third, cost efficiency. LoRaWAN offers flexible deployment models, including CAPEX and OPEX options, allowing for cost-effective and easy network densification to achieve scale and return of investment. It also supports roaming between public and private networks, as well as terrestrial and satellite networks. Compared to Wi-Fi or cellular technologies, LoRaWAN trades bandwidth for reliability, coverage, and battery life, which is exactly what building automation needs. Now let's proceed with the well-known bestseller of ours, the Wiki. Our smart radiator thermostat and the first LoRaWAN-based TRV ever pioneered. Now, with more than 8 years after its release, the device is constantly evolving, providing unique features and still the best-selling LoRaWAN TRV on the market. Recently, we also make it the most robust one, but more on that later. In non-residential buildings, heating remains one of the largest sources of energy waste, mainly because it is static, manual, and poorly balanced. Wiki turns each radiator into a connected, measurable, and controllable asset. It continuously monitors room temperature, detects open windows, and adjusts heating automatically based on real conditions and not assumptions. Thanks to LoRaWAN, the device operates for up to 10 years, or even more in some cases, on a single battery, requires no wiring, and can be deployed at scale with minimal disruption. What is especially important for larger buildings is that Wiki is certified for automatic hydraulic balancing, helping systems distribute heat more evenly and reduce unnecessary energy losses. The result is up to 35% reduction of heating costs, improved comfort for occupants, and a solution that is fully compatible with the existing infrastructure and open platforms. What is important here is that this is a proven and mature solution and is not an experiment. It is LoRaWAN certified, ensuring reliable operation and long-term interoperability in large non-residential deployments. The device is fully FCC and CE certified, and the key advantage is our FWOTA, firmware upgrades over the air, which allows functionality and improvements to be deployed remotely without any on-site interference. And of course, it is proudly designed and manufactured in Europe, in Bulgaria, with a strong focus on quality and durability. Here I want to address the topic that is often underestimated, but it's very important, especially in Germany, and has a huge impact on energy efficiency, hydraulic balancing. Wiki is TÜV-Rheinland certified for automatic adaptive hydraulic balancing, meaning it can continuously balance an unbalanced system without manual intervention. In practice, this leads to more even heat distribution, fewer overheating zones, and lower system losses, especially in older buildings. This certification is also important because automatic hydraulic balancing is a core requirement in many European funding schemes, such as BEC in Germany. Depending on the project, this can support partial funding, often 15% of the investment, while at the same time improving comfort and reducing energy waste. Now, this comparison, very soon we will be switched from normal backplates to the robust backplates, because that one has metal particles inside of it, which make it more than 6 times stronger than the normal plastic ones. And actually, with that new backplate, we are making the Wiki the strongest TRV on the market. Okay, that was our Wiki, and now it is also available in black, also known as the Batman version of the Wiki. Yes. Now proceeding to other devices from our MClimate range. The wireless thermostat, which is designed for zone-level climate control in larger spaces, measures temperature, humidity, runs on e-ink display powered by a solar panel, and requires no maintenance. It is ideal when you want centralized control without wiring, especially in retrofit projects. Works incredibly well in combination with the Wiki, with its sensor, which can be placed on better positioning. It can also improve everything, including energy and also the comfort of the occupants. The next one, fan coil thermostat, all-in-one retrofit device for 2 and 4 pipe fan coil units. It enables precise indoor climate control and typically delivers up to 30% of initial energy savings without changing the existing HVAC infrastructure. Melissa, maybe you know it, because before that we have it in the Wi-Fi version. That was our last device in Wi-Fi. Now, very soon, we will have an upgrade of that device, which is made for split AC units, and now it will also be available in LoRaWAN. Okay, we move forward with one of our simple but very practical and unique devices, our relays. The 16 amps switch and power meter allows both control and measure of the electricity consumption at a circuit or device level. It is typically used for lighting lines, large appliances or specific electrical loads where visibility is missing today. The key value is you don't just switch, you actually see where the energy is going, which is essential for real energy optimization. The dry relay focuses purely on remote on-off control. Without energy metering, it's ideal for simple automation use cases, enabling or disabling equipment, enforcing schedules, or integrating external systems into a smart energy logic. Like all devices, those two are also remotely managed and updated over the air with water, making it very easy to scale. Okay, we switch now to smart energy management, which is not possible without good data from the space itself. And this is where sensing and automation come in. HNT plus peer lights, which is one of our brand new devices. We combine in it temperature, humidity and real occupancy detection in one device. This allows heating, cooling or ventilation to react to actual room usage, not assumption or fixed schedules. The CO2 plus peer light, the CO2 plus peer sensor adds air quality awareness on top of occupancy. It enables demand-driven ventilation, ventilating only when CO2 levels and real presence requires it, which improves comfort and avoids unnecessary energy waste. And the peer sensor, which is also coming soon, but it is available to check on our booths, is for simpler use cases. The peer sensor provides reliable motion detection, triggering automation logic such as setback temperatures, lighting control, or alerts when spaces are unused. Together, these sensors make buildings context-aware. Systems react to people, air quality, and real conditions instead of running blindly. And now the rest of our CO2 range, maybe that will be very important for you. The CO2 display light focuses on simple, always visible CO2 information. It is solar powered, maintenance free, ideal for schools, classrooms, or offices where occupants should immediately see air quality levels. The CO2 sensor and notifier adds instant feedback through LED or sound alerts. When CO2 levels rise, people are notified immediately without the need for apps or dashboards. The CO2 display, the big version of it, combines air quality, occupancy detection and larger e-ink screen, making it visible for more advanced environments where both awareness and automation logics are required. Smart energy management doesn't always rely on complex devices. Very often, sensors provide the most valuable signals. HNT sensor, for example, continuously measures temperature and humidity, providing reliable baseline for data climate optimization. It is ultra-low power, long life, and ideal for spaces where stable indoor conditions matter. Open-close sensor detects windows and doors in real time, enabling immediate energy savings actions, for example, stopping heating or cooling when a window or a door are opened. Multi-purpose button. The multi-purpose button adds human interaction to automation. With configurable clicks, it can trigger predefined actions from comfort requests to maintenance or room status signals or even for security measures. These small devices act as event triggers, turning real-world behavior into automated, energy-efficient decisions. And last but not least, our water control and leak prevention solutions, because energy efficiency is critical, but water damage can destroy value overnight. The T-valve. The T-valve allows remote water shut-off in case of detected leak. It works autonomously, has a long battery life, and can also be operated manually if needed. This is especially relevant for technical rooms, basement, or critical water lines. The flood sensor, its partner in crime, detects leaks immediately at floor level and sends an instant alert. No wiring, no infrastructure changes, just fast reaction when it matters most. Together, these devices turn water from a hidden risk into a controlled and monitored asset. Up to this point, we talked about devices. Now this is where everything comes together, because we are not only the manufacturer of the hardware, but we are building our software as well. MClimate Enterprise is a plug-and-play IoT platform that gives you full control over all connected devices from one place. You can monitor live data, analyze historical performance, and create smart schedules based on occupancy, time, and real building usage, not assumptions. The platform also supports hydraulic balancing, mold detection, automated alerts, reports, and user-based access control, which is critical for larger portfolios. And most importantly, it is open and scalable. It integrates with LoRaWAN network services and can work alongside existing BMS or third-party systems. On these slides, you can see how real deployments across Europe and the UK, different buildings, same scalable LoRaWAN approach, proven in practice. Okay, now real-world examples, sorry. Okay. Moving to some more specific ones, the office building in Germany and school in France, no major retrofit, around 30% heating savings and return of investment within one heating season. And this is a heritage building in London dating back to the 16th century. Nearly 1,000 smart radiator thermostat of ours, the Vickies, were installed without alerting the historical structure. The result? Around 30% heating cost reduction, full compatibility with existing valves, and return of investment within one heating season. To summarize, the challenge is clear. Existing buildings must become more efficient, smarter, and more sustainable without heavy renovation. What we show today is that this is already possible using proven, scalable technology that works in real buildings today. MClimate helps turn energy waste into measurable control, cost saving, and long-term value. I am Miroslav Dimitrov, and today I shared how smart energy management works best in non-residential buildings. Thank you for being here, and I'm inviting you to our stand, which is over there. Thank you for your attention. It was a pleasure to speak and present the presentation in front of you. Thank you. Okay.